something in deep space has defied every model we've trusted. Hidden among ancient constellations and cold galactic voids, astronomers have stumbled upon anomalies that simply shouldn't exist. A glowing blue planet where glass rains sideways at 7,000 kilometers per hour. A floating hexagon on Saturn's north pole that never shifts. And then an object so distant, yet so precisely aligned, that it bends light itself into a cross. The Einstein cross. Each of these discoveries points toward a universe far stranger than we imagined. But perhaps the most unnerving rogue planets, massive untethered worlds, drifting through the cosmos without a star. How do such planets exist without being pulled into a solar system? And more importantly, are they truly lifeless? These questions aren't theoretical anymore. Over the past decade, space agencies like NASA and ESA have confirmed dozens of interstellar oddities, from ringed asteroids to gamma-ray bubbles stretching above and below the Milky Way. These are not just abstract puzzles for astronomers. They're warnings that the physics we rely on may be incomplete, or worse, fundamentally flawed. So how did we get here? For centuries, humans looked to the skies with myth and wonder. But only in the last few decades have we had the tools to see what truly lies beyond Earth's fragile atmosphere. And what we've found, from the chaotic surface storms of Jupiter to the silent gravitational distortions light years away, has forced a disturbing reevaluation. Take the case of asteroid Chariklo. At first, it seemed like just another rock drifting quietly beyond Saturn. But astronomers watching its faint glow noticed two thin rings, perfectly symmetrical, seemingly suspended in defiance of Newtonian mechanics. No asteroid should have rings, not without a stabilizing force. That led to a chilling hypothesis: Chariklo might have its own hidden moon. A moon we've never seen, but whose gravitational influence is holding the rings in place. It was the first time a ring system had ever been discovered around an asteroid. The implications. If objects as small as Chariklo can maintain complex structures, what else might be lurking in the vast spaces between planets? Undetected, unclassified, misunderstood. And what are we truly seeing when we look into the deep field? Is it light from ancient galaxies, or echoes of something else? In a time where data from interstellar objects like 3I, Atlas raise alarms, and space telescopes monitor strange green flashes near Mars. These questions are no longer confined to astrophysics. They're entering public consciousness, forcing us to rethink the rules of the universe. This is no longer just about exploration. It's about confronting the unknown and how little control we truly have. What else are we about to discover in the sky that shatters what we thought we knew? When astronomers first detected the so-called rogue planets, it wasn't with celebration. It was with disbelief. These weren't exoplanets orbiting a distant star, like Earth does the Sun. These were entire worlds, untethered, wandering alone through the galaxy, subject to no known orbit, moving freely through interstellar space. They don't emit light. They don't reflect much. They're almost invisible. And yet scientists now estimate there could be hundreds of millions of them just within our Milky Way. How did they end up alone in the dark? One theory suggests they were formed in star systems like ours, but were violently ejected after gravitational disruptions. Perhaps a nearby supernova or a planetary collision. Another possibility is even more haunting, that these planets formed in isolation, never attached to a star, birthed alone in a cold nebula, and condemned to drift forever. Whatever the cause, their existence challenges the very idea of what a solar system is. If these planets can exist independently, what defines a planetary system anymore? And could rogue planets' massive, insulated, potentially geothermal support life in total darkness. It's not impossible. Some scientists suggest that internal heat from radioactive decay or friction might allow liquid oceans to exist beneath thick ice layers, similar to Europa or Enceladus. If that's true, it means entire ecosystems could be thriving in the black, unreachable, undetectable, and utterly alien. Meanwhile, closer to home, other anomalies are being uncovered. Consider HD 119733b, a massive gas giant exoplanet located about 64 light-years from Earth. Unlike rogue planets, this one is very much bound to a host star. But what makes it infamous is its color and atmosphere. It appears deep blue not because of water or oxygen, but due to high-speed glass rain. Literal particles of silicate glass whipped by winds traveling at 7,000 kilometers. Temperatures soar to over 1,000 degrees. This is a planet designed by chaos, not comfort. And yet it's not without intrigue. Traces of methane and carbon compounds have been detected in its upper atmosphere molecules that under different conditions are often associated with biological processes. Could these be remnants of a pre-collapse biosphere, or something else entirely? The discoveries pile up gamma-ray bubbles known as Fermi bubbles, erupting from the center of our galaxy, invisible to the naked eye, but spanning 12,000 light-years in both directions. Their origin remains unknown. A relic of black hole activity, a galactic wind from long-dead stars. No one can say for sure. And then there's the Einstein cross. 4 identical images of a single distant quasar, bent around a galaxy, 8 billion light-years away. What we're seeing is not multiple objects, but the same one, repeated by the warping of space-time itself. It's as if the universe is holding up a mirror and asking, "What are you really looking at?" The more we learn, the more we realize these are not isolated discoveries. They are part of a pattern, a growing list of cosmic evidence that suggests we are on the verge of confronting something we cannot yet explain. Among the countless mysteries that litter the cosmos, one stands out not for its beauty, but for its persistence, the Great Red Spot on Jupiter. It's not a crater, not a continent-sized stain, but a storm. A vast churning cyclone, large enough to swallow Earth twice over, raging for more than 350 years without pause. It was first observed in the 1600s, and despite technological leaps, we still don't fully understand what's fueling it. Why hasn't it dissipated like hurricanes on Earth? What kind of energy source can sustain something so violent for so long in the open atmosphere of a gas giant? Recent data from probes and telescopes suggest its depth may extend hundreds of kilometers beneath the visible cloud tops, with turbulent chemistry unlike anything on Earth. Hydrogen, helium, and complex hydrocarbons twist in layers of temperature gradients that defy expectation. The longer we watch, the more the spot changes in shape, in hue, and diameter. But it never dies. It's as if the planet itself is alive and pulsing. Now contrast that with Saturn's North Pole, where a geometric formation unlike anything natural appears in perfect symmetry. A hexagon, first spotted by Voyager in the early 1980s, and later studied in high definition by the Cassini spacecraft. This shape isn't drawn on by storms. It is the storm. A 6-sided jet stream, spanning nearly 30,000 kilometers, motionless in its position, seemingly locked into place by forces we still can't fully simulate. Fluid dynamics models have tried to replicate the phenomenon in labs using spinning liquids, and while patterns do form, nothing comes close to the consistency seen on Saturn. More chilling is how the hexagon's color changes over time, possibly responding to Saturn's 30-year seasonal cycle. What kind of atmospheric chemistry does it take to create shape and hue like this from millions of kilometers away from the Sun? And what does it mean that the same geometric consistency appears nowhere else in the solar system? If natural, it's a fluke of unimaginable rarity. If not, we're entering dangerous speculative territory. And still, the strangeness continues. Deep at the center of our own galaxy, past the spiral arms and dust clouds, scientists have observed emissions of gamma radiation lethal to life as we know it. These emissions form massive lobes above and below the galactic plane, known as the Fermi bubbles. Spanning tens of thousands of light years, these formations glow faintly in gamma and X-ray bands, and may have been created by ancient explosions or a past phase of black hole activity. But no one knows for sure. The symmetry, the energy scale, the sheer emptiness between them, it all suggests a galactic event of unfathomable magnitude. If confirmed, this could mean that our Milky Way is still echoing with shock waves from a violent, forgotten past. And then there's the most philosophical discovery of all the Einstein cross. A single light source warped into 4 reflections by gravity alone. Found in the constellation Pegasus, this object reveals the true power of mass to bend space-time. What we see is not science fiction, it's literal proof that Einstein's predictions were correct. But it also raises disturbing questions. If space and time can be bent, can they be broken? Can reality fracture in ways we haven't yet conceived from 3i? Atlas. Changing behavior near Mars. To mysterious green flashes picked up by NASA's newest sensors. There's an unmistakable pattern. The cosmos isn't just expanding, it's reacting. But to what is it? Instruments, or a larger process we have yet to name. These aren't isolated phenomena. They're converging signs, a symphony of distortion energy and unknown forces. All of these phenomena, the rogue planets, the Einstein, cross the Great Red Spot, Saturn's hexagon, the Fermi bubbles. They aren't just isolated wonders. They're fragments of a larger cosmic puzzle we've only just begun to assemble. For centuries, we assumed the universe was cold, static, predictable. But each new discovery pushes us further from that comforting illusion. Consider the magnetars, a subclass of neutron stars, so dense and so magnetically unstable, they can distort matter and obliterate electromagnetic fields across vast distances. Just 10% of all neutron stars become magnetars, but their existence is a constant threat. A single magnetic flare from one of these dead stars could erase electronic systems on Earth or render entire regions of space uninhabitable. Some scientists now suggest that entire planetary systems may have been sterilized by magnetar activity. Worlds that once held oceans' atmospheres, even life stripped bare in seconds, reduced to silent, scorched rock. That may sound like science fiction, but the math behind it is real. And so is the fear. We often talk about the search for intelligent life aliens, signals, biosignatures. But what if the silence is the answer? What if something is out there, but it doesn't speak? What if it only destroys? At this point, the question isn't just what's out there, but whether we're truly ready to know. Our telescopes are sharper, our sensors more sensitive, our models increasingly complex, but understanding doesn't always bring comfort. Sometimes it brings dread. If the universe is more violent, more chaotic, and more sentient than we believed, then what role do we really play? Are we observers, survivors, or intruders? In the last few years, patterns have emerged, objects behaving unpredictably, emissions that don't match known sources, gravitational anomalies that can't be modeled. NASA's own data delays, such as those surrounding 3I Atlas during its Mars flyby, have raised eyebrows in the scientific community. And then there are the green flashes, brief bursts of unexplained radiation visible across instruments, but absent from public reports. Is it all coincidence? Or is the cosmos beginning to reveal a side we weren't meant to see? Perhaps what we call anomalies are actually constants, and we're the variable. A fleeting species stumbling into a realm far beyond our grasp, with instruments too crude to comprehend the full picture. We left Earth looking for answers, but what if the universe only responds with more questions? One thing is certain, we've crossed a threshold. From here on, every discovery may not just alter our understanding of space, it may redefine our place within it. So now we ask you, if the universe is stranger than we ever imagined, what do you think we'll find next?